Fifth graders, today is Tuesday, September 17th, and we are continuing along with Eureka Math Module 1, Lesson 12. As you know, yesterday we talked a lot about using the place value chart and area models to multiply a decimal number by a whole number. At this point, after all your extensive practice in class and at home and on Zern and in your workbook, you should be a pro at using a place value chart to make copies using the dots and regrouping, and also using the area model. Okay? Today what we're going to do is we're going to kind of add on to that knowledge. We're still multiplying decimals by whole numbers, but what we're doing is we're using estimation. I want to show you a different way you can use what you know about multiplying numbers to extend that knowledge to multiplying decimals. Okay, you'll see what I mean in just a second. Let's first talk about the problem of the day. The directions tell us to round in order to find an estimate. That's the first thing we're going to do. We're not even going to solve anything, no area model, nothing. We're just going to round to find an estimate. Okay, so 2.1 is pretty close to what number? 2. Good. By the way, this wavy, do you guys see how that's a wavy equal sign? That means I'm rounding. It means I'm finding an estimate. Okay, 2.1 is pretty close to 2. 3 is already an easy number to work with. So, what's 2 times 3?
6.
Do you see how when we use estimates, it tells us, hey, our answer should be pretty close to 6. Do you agree? Why did I use a wavy sign here and I didn't use a wavy sign here? Do you see how this is an equal sign and this is an estimate sign? How come? Because is 2 times 3 close to 6 or is it exactly 6? Okay, so be careful. Now that I know that the answer should be close to 6, here's what I can do. I know I have 2.1 times 3. Well, I could just think, I'm going to ignore the decimal point for now. I have 21 times 3. Do we know how to do this math? Absolutely. What's 3 times 1?
3.
What's 3 times 2?
6.
Or 3 times 20 rather, is 60. So 21 times 3 is 63. If I know that I need my answer to be pretty close to 6, where would I need to put the decimal point? If I put the decimal point here, what would my answer be? 63. Is that pretty close to 6?
No.
What if I put my decimal point here? What's the answer? 6 and 3/10. Is that pretty close to 6?
Yes.
What if I put it here?
No.
What would the answer be?
0.6300.
Not 0.63 hundredths, it's 63 hundredths. So, would that be close to 6? Where would be the best place to put the decimal point so that my answer is close to my estimate? Well, 6.3. So do you see how you can use estimation to help you figure out where the decimal point should go? Let's try that again. Our next problem is 7 times 6.053. Okay, 7 is 7, but 6.053 is pretty close to what whole number? Everyone?
6.
So what's 7 times 6?
42.
That means that our answer should be pretty close to 42. Now I can multiply without worrying about the decimal point. I like to put the longer number at the top. You can choose to do it differently, but I like to go like that. Okay, let's multiply. What's 7 times 3?
21.
I record the 3 and I put the 2 on top. I regroup the 2. Yes? Because they're in the tens. What's 7 times 5?
35.
Plus 2?
37.
Good. What's 7 times 0?
0.
Plus 3?
3.
What's 7 times 6?
42.
Okay, so I have 4, 2, 3, 7, 1. Because my estimate said that my answer should be close to 42, where should I put the decimal point? Here?
No.
Here?
No.
Here?
No.
Here?
Yes.
Good. Okay, so this serves as a reminder for you for 2 things. 1, you should know how to estimate. And when you estimate, you're finding an answer that's pretty close to the real answer. And the whole point of estimation is to be able to do it in your head. Okay, so that's why you want to round to the nearest whole numbers, because we know our math facts. The second reminder is that in 4th grade, hopefully you got a lot of practice multiplying using the standard algorithm. Not just single digits, but hopefully multi-digits too. Yes? If you're a little rusty on this, you're like, whoa, Miss O, you're going really fast with those numbers. You need to practice that. Okay? I'm assuming you know how to do this stuff. If you don't, you can come ask me for help. Be honest with me and with you. Okay? I'll help you. But I'm going to first assume that you guys know how to do that. Okay. Try the last one by yourself. For this first question, it says 5.1 times 6. Yes? What's another way to say 5.1 where there's no decimal point? So if I got rid of the, 51 tenths. So that means that this question is the same thing as 51 tenths times 6. That also means I could rewrite it like this, 51 tenths times 6. And you'll notice there's no decimal point there anymore. Now I can multiply. Whenever I want to multiply using the standard algorithm vertically, I cannot do it if there's a decimal point there. Okay? Do you guys see that? See how there's no more decimal point. Now I can multiply. What's 6 times 1?
6.
What's 6 times 5?
30.
Great. So 51 times 6 is 306. But what's my units?
Tenths.
Good. So in unit form, my answer is 306 tenths. How can I write that in standard form? Well, I know that I have 306, and I want my rightmost decimal or rightmost place, value place, to be in the tenths. In order to make that happen, I have to put the decimal point there. So my final answer, 5.1 times 6 is 30.6. Let's quickly use what we know about estimation to see if that's correct. 5.1 is pretty close to? 5 times 6 is?
30.
So my answer should be close to 30. Is it?
Yes.
See how you can double check yourself? You can rename the units so that to get rid of the decimal point. Keep that, write it in standard form, and use estimation to check. Let's try another example. 312 hundredths times 4 is 1,248 hundredths. Good. And if I want to write that in standard form, how do I write 1,248 hundredths? Well, I can write the digits 1, 2, 4, 8 in a row. And I want the 8 to be in the what's place? Hundredths. So Sushant, where does the decimal point have to go in order for the 8 to be in the hundredths place? After the 4, right here? In between the 2 and the 4. Let's use estimation to make sure that this is correct. 3.12 is pretty close to what whole number? 3. 3 times 4 is? 12. Is this pretty close to 12?
Yeah.
Very good. Try this one by yourself. 4 times 5.733. First, rename the units, then multiply, write it in standard form, and then use estimation to check. As a review, I want to remind you that we talked about unit conversions. We talked about kilograms, milligrams, grams, etc. Yes? So I wanted to add on to this part to the problem and have you convert. I want you to find out how many grams are in 33.2 kilograms. We want to find out that equals to how many grams. Well, the first thing you need to know is 1 kilogram bigger or smaller than 1 gram? Bigger, right? How many grams are in 1 kilogram? 1,000. So if I have 33 kilograms, will I have more or less than 33 grams? More, right? So do I have to multiply or divide? How many grams are in 1 kilogram?
1,000.
Good. So use that to see. You have to do 33.2 times 10 to the third power. Remember, we also need to remember that we learned about exponents. How did the number shift when we multiply by factors of 10? To the left or to the right? Good. So how many times are they shifting to the left?
3.
Good. So when that happens, what would the answer be?
3,200 grams.
Very good. Okay, so this is a gentle reminder that you need to remember how to convert. You need to know when to multiply, when to divide, and by how many factors of 10. Okay, that's coming up.